My name is John Jørgensen. I'm a professor in space technology here at the Danish Technical University. And my talk today is on the subject of mankind and what the moon holds of opportunities for us as a species and of course for our society. It may not be obvious to all of you that there is opportunities hidden in the moon, except from the gloire of going there and being an astronaut walking around and doing big steps for mankind. But it actually holds a lot of other opportunities that I think I would like to share with you some dreams of. The first thing is that the moon has been there for so long, and it will be there long after we are gone. And it's our nearest solar system body. It's a satellite to the Earth, so it's really part of the Earth-Moon system. But it's very, very different from the world we know. Obviously, everybody knows by now that there's no atmosphere. There was a time where we thought there were little green men living up there in the valleys. We thought we saw oceans there, until we got so close that we could see that this was certainly not the case. But the moon has other stuff that may not be obvious to the average journalist, and therefore will never be brought to your ears. And this is what I will try to talk about today. It's such the moon, as because of what it is and where it is in space, can offer us a lot of stuff that we do not have presently available at the Earth's surface. One of them is that we only have one sample of how the solar system was formed that we know in details. That will be the Earth itself, where we are now, and we know pretty much how the Earth was formed, how we think it has been constructed, and what it has received from space after its birth. But we know very little about the other solar system bodies. And it is very difficult to talk statistically about a phenomena until you have seen more than at least one example. And the moon offers actually a unique opportunity to study this. It also tells us a lot about how the solar system is formed. If you look at a photo taken by a satellite of the backside of the moon, the face of the moon that constantly faces away from the Earth, and compare that to the side that faces us, you will note a dramatic change in the surface. This is because the backside of the moon never was shielded from impact from deep space as the front side is. The front side of the moon pointing towards Earth will never be hit from a stone that comes out from deep space. It will either hit Earth or pass the moon, whereas the backside is actually being pelted and is full of craters, very big craters. This indicates obviously that Earth has received the same kind of bombardment once long ago. Now these bombardments have ceased because the solar system is maturing this year, which I think we should be quite happy for, so we do not get the same demise as the dinosaurs. But I mean, it's not all over. Stones are still falling around. But the moon as it is now actually forms an opportunity to make new bases for scientific research, bases for other applications. If we want to study how humans can live in other worlds, this is a very good place to go, because you can also go back with not so much difficulty. It offers a very unique opportunity for astronomical observatories. The reason for this is that it has no atmosphere. I'll get back to that in details very soon. It also offers opportunities for exploitation, not just exploration of our solar system. Exploitation will probably take the form in mining first. It also gives a very efficient transport back to Earth. The moon has a very weak gravitational field, and it's relatively easy to get from the moon to the Earth, whereas it's rather difficult to get from the Earth to the moon. And this actually makes it much simpler to transport stuff back from that we might want to transport back from the moon to the Earth. The moon has no atmosphere. For this reason, the solar wind is directly interacting with the dust of the moon. And this means that the moon is actually being constantly charged with an energy source that we do not have on the surface of the Earth, namely helium-3. Helium-3 offers an opportunity for a totally new energy source that we never have exploited as humans. We can make small artificial solar power plants here on the surface of the Earth with a relatively modest transport job from the Moon. And then, of course, it offers something that I hope that you all cherish as well, namely an opportunity for making a collaboration worldwide between nations, which usually is a very good way of making friends. So this is one of the reasons that I personally like the idea of having International Space Station. I cannot see much other reason for it. As is, there's too much noise with all the astronauts tramping around, so our instruments are constantly being harassed by their motions, and they do only sleep 6 to 8 hours a day. So I mean, that's another reason why we'd like to get to the Moon. And finally, it would be very nice to have a stepping stone if we ever want to expand out of this world. Our world right now is being slowly filled with people. I know that the WHO says that the human population on the surface of the Earth will maximize or reach its maximum peak at the present at around 2050. At that point in time, our population will stagnate at approximately a level of 17 billion people. That's a lot of people, and I think most of you like to have room around you. Out there's room as much as we like, but of course we need the technology to do so. It's a stepping stone for this. And then of course the Moon has never been researched, and every time a researcher looks into something, they discover something new that we didn't know. I mean, it's so easy to think that the world is just your living room when you're sitting in there. It's a big shock to go out on your lawn to realize there's a big new world out there. The same is happening for planets, obviously. This is a totally new knowledge set that we can gain. So, first of all, how did the Moon form? And this is very important to understand why the Moon is important for humans as such. The Moon, we think, was formed about some 3.7 billion years ago, when a planet or an asteroid the size of Mars ran into the Earth that was before then. This impact was so violent that the entire Earth melted. When you splash a stone into some sand or into water, you will see some stuff splash up. This ejecta was also coming out from this collision, and this ejecta was then spread out into the near range around the new formed Earth, and was of course rapidly cooling because small droplets cool much faster than big objects. These gravels then slowly formed and collected themselves into what we now know as the Moon. So the Moon is formed from already frozen, stiff gravels, stones, rocks, formations like they may be a few kilometers across from the biggest crumbles and into very small dust. And that is what we think, why we think the Moon was formed like this. If you then think about what happened to the Earth at the same time. The Earth was of course being hit by this enormous, gargantuous stone, and the energy released melted all of the Earth again. So at least at that point in time, the entire Earth was one red-hot glowing lump of molten whatever it was made from. And as you all know, when you go into the bathtub and bring a rock or a lump of iron, it will sink to the bottom. The same thing happened to the Earth. All the heavy materials sunk into the center of the Earth, and all the light stuff floated up. Everybody in here think that the Earth is made from what? Yeah, from rock, right? Rock out here. This cannot be true really, because the gravity, the specific gravity of Earth is about 5.7. That means that it's much heavier than any kind of rock we have around. It's made from something much heavier, mostly iron, which is in the core of the Earth because it's sunk in. But also all the other nice materials we'd like to have, all the rare earth. If you follow the press these days, people are talking a lot about rare earth. They're rare because, well, they're rare information, but they're also segregated out and is now deep in the Earth, core, a place where we can never reach it because it's so hot. So even if we wanted to mine for these heavy materials, they are now so deep down into the center of the Earth that we can never touch them as humans. The deepest we ever dug into the soil is about 13 kilometers drilling. At that point in time, the drill head will actually start to melt because it's too warm in there. So, I mean, you cannot really go this deep into the Earth and try to do mining. So all these minerals are actually lost for humanity forever. So we have to live with the leftovers that happen to be near volcano eruptions that has brought molten material up to the surface of the Earth and then solidified there, or similar geophysical processes. The rest of all the nice heavy materials that are so much needed from our industry and from the what we call welfare generators, the industry, high technology, is actually lost for us on the surface of the Earth, whereas on the Moon, they're still on the surface. There's a big, big difference. There's not enough time to talk about all these technologies, but just think of one thing. If you want to make efficient transportation on the surface of Earth for humanity, the best medium distance method we have right now is trains, railways. Railways have an upper limit to their speed, and it's very expensive to drive faster on railways because the railways themselves will set oscillation up with the wheels that are running on them. And this problem has been a limiter for the speedness that you can use for trains. And even worse, it costs a lot of energy. It would be much, much easier if we could make magnetic levitation for the trains. Just let them float on a magnetic field. This is very easy to do if we can get strong permanent magnets. Strong permanent magnets need special metals that we do not have abundant on the surface of the Earth, but they are very abundant on the surface of the Moon. If we had a piece of the Moon that we could mine here on the Earth, we could make magnetic levitation trains the order of the day, meaning that you could travel with 1,000 kilometers per hour between cities, floating just 20 centimeters above the railways, without any noise, obviously, and very, very cheaply in energy. Such stuff is not possible today, and I mean, just think of what that would mean for humanity. This is just one example. So the Moon is not like the Earth at all, and of course we'd like to get access to these resources. Another thing is, of course, just out of curiosity, what happens to the solar system and the solar system dynamics. We can learn a lot from the Moon, and this is of course a pure scientific goal, but it also tells us whether we would be wise or unwise to try to spend more money in searching for near-Earth objects that may or may not hit the Earth. It's of course a big debate somewhere in science. We could also make lunar bases. To make a lunar base and not to have to transport everything up there from the Earth would of course call for minerals to be exploited up there. The first I would like to talk about the reason why we would have a lunar base at all. A lunar base would of course be the precursor for real mining on the Moon, and for other reasons too. One of them will be one of the reasons why we would like to have lunar bases, and that's actually being studied right now, both by NASA and the American space authorities, and ESA, the European space authorities, and the Chinese for the matter, and the Russians for the matter, is of course to look for minerals and the helium-3 I was just talking about. And at first there will be research facilities for this, and they will try to map the minerals and later on the geology, and of course also increase our knowledge in the physics of the lunar system. The Moon also offers a very unique opportunity to watch Earth carefully from elsewhere, so it's very good for surveillance purpose. And then of course it forms, such a lunar base will form a fantastic stepping stone for the trip to Mars, and that's another thing being studied right now. The first of these research facilities are going to be entirely robotic. Right now we are talking about the Lunar Robotic Village as a study object for what we're trying to do. One thing this is actually the wettest dream of any astronomer, is to have a huge telescope on the surface of the Moon. The biggest telescope we have on the surface of the Earth is the Arecibo antenna, which is gargantuous. You have seen it in many movies, James Bond and so forth. But it's actually a huge telescope that is very, very powerful. It's a big crater that they built a real telescope in. The biggest telescope we are presently having, optical telescopes we are presently having on the surface of the Earth, are 8.4 meter telescopes. There are two 10 meter telescopes at Mauna Kea, the rest is in South America. And these telescopes are as powerful as an astronomer and astrophysicist can really use. Any larger telescope is not really meaningful because the Earth's atmosphere kills all the red light that comes from above. It's killed by our atmosphere. As you know, infrared light is being absorbed by water. You probably heard about greenhouse effects and stuff. That's what they're talking about. Water and also carbon dioxide eats any infrared light and beyond, so we cannot get heat radiation from the universe. Because the universe constantly expands, it means that the light that comes from far away is redshifted, being more and more red the further away it comes from. And that means that there's a limit to how deep you can see. So from the Earth we can only see a certain amount of the sky around us from the surface of the Earth. This is why we make space telescopes. Space telescopes are great, I mean they're beautiful. The problem with them is that they are limited in size because they can only be as big as what we can make on a go up with one rocket. So right now the biggest space telescope we have is something the size of the Hubble telescope. On the surface of the Moon we could easily make gargantuous telescopes. And the reason why we can do this is because the Moon has no atmosphere. That means that we can see the red light. We can see very, very much deeper into the skies than we can ever do on the surface of the Earth. There's no human activity, at least at this point in time. That means that there's not so many cars going about. This is one of the limiters on the surface of the Earth. All astronomical telescopes at the Earth right now is being hampered in their operations by cars moving around them, or even a person walking next to the building actually shakes the telescope too much. I mean, already our good old Tycho Brahe had to move his observatory from the Copenhagen. Light pollution, and of course, but mainly the rumble from the horse-driven carts that drove past this building. So he already had to go to the island of Lee already many hundred years ago. It's much worse nowadays with a much bigger telescope. This is one of the big benefits of going to the Moon for this. And there's very low seismic activity. Earth is constantly being pelted by small earthquakes. Even in Denmark, we get many thousand earthquakes every day. They are very minute, obviously, so we do not feel them, but they are there. A telescope certainly sees this. That's also not seen on the Moon. And then finally, we can stay on target for a long time if we are on the Moon, because the Moon has such a slow rotation. Earth has a rotation period of, as you know, 1 day. The Moon is, of course, 28 days. These are the reasons why this is actually a very sought after facility on the Moon to make a big telescope up there. The minerals, where do they come from up there? They come in two forms, really. There's the form that the rocks that form the bulk of the Moon was collecting up through the eons of billions of years after billion of years after this object hammered into the old young Earth and remelted the entire planet. And all the ejecta came out and made this dust cloud around the Earth. Those rocks, of course, contains all the heavy materials, but there are also lighter materials on the surface of the Moon. They are mainly brought in by asteroids that hammered into the lunar surface after the Moon was formed. And that gives a lot of impact craters. Those are the ones you can see. You can see some of the bigger ones here from the surface of the Earth. I mean, even with the naked eye, you are able to see the very big craters like the Tycho crater on the surface of the Moon. And if you study these, you find the mineral content. What you see here is actually a photo taken by the Hubble Space Telescope. And this is just showing the green stuff here, green-yellow stuff, is the mineral called ilmenite, which is just titanium oxide. A very sought-after material here. That we do not have that much titanium in the Earth right now. You all know that almost all titanium deposits on the surface of the Earth is in what was the former Soviet Union, mainly in Russia. The Russians are the only ones that have ever afforded to make a nuclear submarine out of titanium because it was so cheap to them. For us, in the rest of the world, we have to pay an arm and a leg for this material. It would be so fantastic to be able to make a car out of titanium. It never rusts, it never breaks. It would be a much lighter car, it would save a lot of gas. We can't do this right now because we do not have enough titanium. And the reason for it is that it's a mid-range metal. It's heavier than aluminum, so it sits lower down in the crust of the Earth, where we cannot reach it, or in a few mountains in Russia, and of course on the moon. I mean, that just tells you that, I mean, one of the reasons why we would like to do this stuff. Mining on the moon, how can we do this? This is, of course, one of the questions that constantly is being raised. Do we need to have tons of humans up there? Well, the first thing that this is Denmark, and you probably heard that we have that people are thinking about making mines in Greenland. That's because Greenland also have minerals. Some of those that I've talked about here, the rare earth, are actually found in pretty big abundance at the surface of Greenland. So is uranium and other sword-forming materials. To mine these, you need machinery, and this is knowledge-based activities, but it's usually machines that are almost robots entirely. There's not so much mining where you have a shovel and an axe going out into and making caves in the mountains anymore. It's actually mostly done by robotic machinery in modern mining. So to move that to the moon is actually not the biggest task. The service of the machines is, on the other hand, a human job. So what we envisage right now is that we have machines almost like those that we have on the surface of the Earth, but they will just have to be maintained by humans. So it's mainly a robotic facility we think of. That's actually the reason why we talk about a robotic village for the moon. Now, deliverance to Earth. How do we get the stuff back to Earth? That's, of course, another matter. On Earth, it will be put the iron or the uranium or the titanium will be put on a truck and go into a melting facility. That will not be the case, and then, of course, transported in bars around to the user. That will not be the case on the moon because we have to transport it back to Earth. And instead of having a spacecraft doing this, it can be done much, much simpler. All you do is that you make a so-called railgun. This is an electromagnetic accelerator. There will be two rails, 3 kilometers long, and then you put your pellet of metal on it, and then you just put a current through it from a solar-driven plant, and then the particle or the pellet will be accelerated up to a speed that is high enough to deliver it and fly back to Earth. Obviously, we have to get the gun pointing correctly at Earth. Now, you have a lump, say 100 tons of steel, then approaching Earth. Of course, you will not need people under the landing spot of this. So we have to take a shallow water area and get this material down to. It will hit the surface of the water with a velocity at around 500 kilometers per hour, typically. So it will be like an aircraft crashing into the water. So it has to be a vacated area, but a shallow water bay would be, well suited for this. It will not be a big problem to do such a thing. It's just, of course, we have to use an area to land this stuff. I think many countries will be more than happy to have an area where we do such a thing, because there's a lot of money, of course, associated with this. To give a perspective of this, if we took the cargo hull of the space shuttle and filled it up with helium-3, we needed about 20 of these per year to supply all the energy used by humanity right now on the surface of the Earth. So it's 30 truckloads, more or less, of helium-3 that we need to transport back every year to keep, then you can forget about wind turbines, wave energy, solar energy, geothermal energy, oil, coal, and in a way that's probably, at least there's a different way of perspective to this. If you want to think about we would probably never move steel from the moon, but other materials like rare earth would of course require maybe 10 truckloads a year to supply the Earth with these materials. So it's of course limited what people to begin with will bring that back down from this. Just to tell you what's going on right now, since 1972, when men last time were on the surface of the moon with the Apollo 17, it has been visited by a host of robotic missions, starting with Luna in 25 in 1976, and then a lot of others doing much different stuff. As you see, it has accelerated over the years. You'll see more and more missions here. DTU is on board the RD that is coming up, well, the end of this year, or maybe end of next year, where we're going to, the topic of that mission, RD, is actually just to see how much dust is in the air of the moon as it is before we start human activities on the surface of the moon. The GRAIL has been, that's misspelled. GRAIL is, was mapping the lunar gravitational field to find out where the deposits of materials really were concentrated on. LRO was mapping the topography of the surface of the moon, so we get a better landing map for this. At this point in time, we have, of course, a pretty good model of the general surface of the layout of the moon surface, and we know where to go to find water in the craters. That's actually what Smart 1 was finding. What are the deep craters of the south pole and north pole of the moon. We have calcium deposits there, and we have all the light materials like oxygen available. So it's pretty easy to make a farm if you put it inside a housing up there, and you can make atmosphere easily from the rocks. So it seems like to make a human habitat up there would not be so difficult in terms of resources. In terms of willingness to do so, it's also a different matter, but that's what the money is for, right? So what people are studying right now is accessibility. The big problem going to the moon is actually to get there. It costs around 250,000 Danish kroner to put 1 kilo into low Earth orbit. And it costs, and you 10 double the price to go to the moon. So 2.5 million Danish kroner to get onto the surface of the moon is the present cost. That's too high to warrant missions up there. But you also probably have heard that NASA has totally rethought their entire launcher program. And the reason for this is to lower cost. The private companies that are presently pushing for new launchers are trying to drive down the launch cost to about 5%, they say, in the long run, but at least to 20% of the present launch cost. And that, of course, makes accessibility much easier. Presently, we at DTU are working with a private company in US that would like to make a lorry kind of truck that goes on the surface of the moon, Earth, and land on the moon and deliver 250 kilos for a price that is the same as it costs right now to get 1 kilo low Earth orbit. And these are, of course, the precursor vessels to do this lunar release they're trying to service. That's a vastly interesting research topic. Of course, it gives us the possibility to get robots on the surface of the moon. It gives us possibilities to get cheap supplies up there for humanity. So that's some of the things that goes on right now with the moon. So I think I overspoke my 15 minutes by 100%. So I think at this point in time, I think it's probably a good time to stop, unless you want to hear a little about the modern launcher technology and stuff. So yeah, I'd like to hear if there's any questions at this point in time. Yes?
For lunar bases on the moon, what do you think of additive manufacturing for how to build a base up there?
Yeah.
What do you think of the technology?
The technology to make a lunar base is obviously one of the challenges that we have right now. What we have been using to make the International Space Station can work to make the first habitats be realized. That is a small, cubicle where people could be in while they're building the larger facilities. The idea is, of course, that the moon has no atmosphere, so one thing we have to be very careful about is meteorites, small meteorites that can puncture light shields. So we need a pretty heavy construction above whatever we put for a habitat up there. So we need actually to transport some material to the lunar surface before we can make a human habitat. That's also in the books right now with the very heavy lifters that the Americans right now are envisaging. But that is to transport the small modules to the surface of the moon using the exact same technology as we used for the International Space Station. However, in the mid-run, I mean just after this imagine you can have maybe 20 people living on the surface of the moon in such habitats. Their job will be to maintain the robots, which are melting materials and making the new materials for buildings. There's lots of building materials on the surface of the moon that you can use. And then to start to dig into the dust, a thin-walled construction would be the next task for these humans, in which you can make make only a small surface area that you can put a thick cover on. This technology is presently known and used on Earth as well for constructions at a local site. I mean, you locally build this construction, you know this from, for instance, concrete is one of the materials that could be used for this, so you can make do with only a thin layer of metal on the inside of this. So this is not new to us, in that we do have the materials to make, for instance, a concrete-like material on the surface of the moon, so for local constructions. But we still will need for a while, until you have a village established, to transport the more subtle elements from the surface of the Earth. Like, for instance, window glass will for a while have to transport it. Window glass is one of the things that is pretty easy to make locally, though. So as soon as you have an energy plant big enough, you can actually start making this. But the point is, for a pretty long series of years, probably 20 years after you establish a lunar base, you will still have to make or bring stuff up from the Earth before you're getting fully self-supplied.
And the manufacturing at the moon could be done with additive manufacturing, for example?
The manufacturing on the moon will the stuff that goes back to Earth is very, very simplistic. It's basically just ovens, heating facilities, and then of course concentration facilities for the stuff that we want to harvest from the moon. There's so much energy, there's so much resources on the surface of the moon that you do not need to extract 100% like we on Earth always try to do. You can easily make do with just extracting the top fraction, and that will easily pay for the entire endeavor to begin with. It's more like for the habitat thing, where you need to have high reliability. You need to have very high reliability on the glass that protects the lunarnauts, or whatever they're called, or the lunar people, from radiation and from stones from above. And that will probably be transported for a while. Any other questions? Okay, but then I will thank you for your attention, and I think it's about lunch break now.